I thought I would demonstrate some cool things about my 3D rendering project that I've done during this my birthday week, where I've taken some time off from my work at Google. So here's my 3D cube, which is actually projected. It's the actual renderer itself is only drawing lines in SVG, and it only knows how to draw lines on a 2D canvas. And there's actually a mapping between the 3D space to the 2D canvas, which I think is based on a pinhole camera. And I think that's why if I make this too long, it goes like this. But I actually don't know because I don't really understand any of the mathematics that I'm using at all. I just implemented it with a ton of tests. More tests than I've ever written per unit code before. So each of these drops it's running at 144 FPS right now. And one of the reasons that I can render so many without dropping any frames, without using a GPU or anything like that, is because I'm actually only I'm not handling any of this on a tick by tick basis. What actually happens is every time the browser, I request a frame from a browser using the frame request API. I essentially say like, when do you want your next frame? When the frame comes up, I know how much time has elapsed between the last frame and this frame. And then I can use kinematics to basically say, this point traveling at this velocity will have traveled this distance in that time. And so when it's not rendering frames, it's not doing any calculation at all, which is, I think quite nice. One of the interesting things as well is that you will notice that the lines are of different length sometimes. So like if the particle is traveling faster, the line will be longer. And I think you would call that a frame buffer effect normally, but I'm not using a frame buffer. What's actually happening here is that the previous, there's 2 points in the line, and the previous point is the previous position that the particle had on the last frame. Net result being, the longer it takes to render a frame, the longer the line ends up being drawn. Which you can see immediately when I open DevTools, and DevTools that's drawing all this stuff, and for some reason I'm using React to draw these paths. I don't know what this is going on here. I don't really care. And so yeah, everything immediately becomes slower as a result, and then all the raindrops get considerably longer, which is kind of fun. I can make that happen even more by going into Performance Profiler and throttling it with the CPU, and we end up with a spaghetti nightmare. Let's turn throttling off. Let's play around with this a bit more. I thought I'd show some of the things that you can do here. So each of these is calculating when a particle has hit a wall, and then it reflects it off that wall. And so if we take this one off, then it should just, the raindrops will fall through the bottom, and they will just keep falling. It will just keep falling forever. I think. Yep. They'll just keep falling. And the interesting way that because I know the position of all the points once I've rendered the shape. Wow, I don't even know what's going on anymore. Because I know the position of all the points once I've rendered the shape, I can always create a canvas that contains all of those points. And that appears as though the canvas is, the camera is panning out. But what's actually happening is that I'm just making the canvas larger to contain all the points. I think a nicer one is taking the top off of the cube. Because that allows the drops to actually keep going up until they start falling again, until their vertical velocity reaches 0, which is, I think, a much nicer physics demonstration. The only issue is that because the canvas size is determined by the things that are being drawn inside it. You get this wiggle as the points that I'm rendering go outside of the bounds of this cube that is containing everything. They do seem to be bouncing maybe a little higher every time. Maybe I'm imagining that. Anyway, that's been my graphics rendering project.